Alright, today we're going to do an overview of our SG43 SGMT semi-auto build parts. So to get the fun part out of the way first, here at Freedom Machine Works, we do not build customer guns. We don't have the resources to be able to do that. What we do is develop and manufacture parts for home builders and hobby gunsmiths and others that like to build their own guns. So generally, most of the parts we sell pick up somewhere after building your receiver, after installing denials and doing all of that stuff there. So what would essentially be that's sort of the neutral point where we start. So like this here, after everything's already welded up, after it's the bolt and the carrier slide through there, everything works fine. Our parts come in sort of where it would be like, okay, now what do we have to do to make this actually fire in a semi-auto only way that would comply with the guidelines that are in place through in the U.S. here. And to do that, it has to be a closed bolt system, has to fire from a closed bolt. You can't have any open bolt semi-autos. And you would start thinking, okay, what am I going to do? How do we light the primer? Okay, we need a firing pin. How do we hit the firing pin? How do we develop a trigger that resets and all these different things? And then how do we do it reliably, right? How do we get a system that that's just going to work like a factory gun would, just over and over and over again without any drama? So that's what we do is we put in the hours and the time to figure that out. To manufacture the parts, material selection, heat treat, all the things that you would need in place to develop parts that are going to last a lifetime. Really, it takes a lot of time to build one of these, and you want to get the most value that you can out of it. And running our internals, we work to ensure that that's what you get. So, legally, we accept no responsibility for the firearm that you build, because again, we don't build firearms. We manufacture parts. We can provide instruction on how to fit those parts, how to install those parts and use those parts. But like if you build a gun and the headspace is too big and it blows up, I mean that's on the builder. If weak welds, or if something doesn't work out, we accept zero liability for anything that happens for the implementation of these parts. Now, if if somehow you manage to break one of our parts, something happens or whatever, get a hold of us. We can work out getting you something new. But as far as liability goes, again, that's 100% on the builder. We don't offer advice as far as like denial features and stuff like that. Read the laws on that and understand it for yourself and make your own judgment call on how you want to approach that and go from there. So okay, let's get into the general aspect of what we've got going on here. And so starting at the front, we have a piston assembly, and this is actually multiple pieces. So in order to get the spring on, the piston is two pieces. You've got the piston body itself and then the piston end, and then the recoil spring, the recoil spring bushing, and the horseshoe retainer. So the horseshoe retainer, what it does, that's what the recoil spring pushes against. So you've got the piston, it goes on the end of the carrier, and it comes back like this. The horseshoe retainer sits on it like that, so that whenever you cycle the weapon, the horseshoe retainer stays in place, piston comes back and allows everything to cycle. And the horseshoe retainer has a cutout here. Make sure I'm in frame. Yeah, it has a cutout here in order to make it easier to get out from underneath in its slot in the receiver. The horseshoe retainer is held in place by this small 832 set screw, and we'll go over how that gets installed here shortly. So from the piston, horseshoe retainer, sort of recoil assembly there, we move on to the firing pin. So this is the firing pin, and this is an anti-bounce spring. Essentially, whenever all of this mass runs forward and it stops, this spring is there to prevent the firing pin from going in on its own and dimpling or risk hitting a primer as a safety feature. So the firing pin has a notch cut out in it in order to be retained inside the bolt. There's a cross pin that goes through there, and the slot allows it to be able to travel across that pin. So from there, we would move on to the striker and guide rod assembly. So here, this is the striker spring here. It goes inside the striker tube and inside, well, the striker assembly. And then the guide rod has a sear on it right here, and it's spring loaded. The spring under there, and there's a 3mm cross pin right here that holds it in place. So the sear goes up inside the striker like this, and this sear catches right here on the front of the striker when it comes together, like that. So then when this is pushed down, releases the striker, which then comes forward, and this face on the striker makes contact with the back of the firing pin, allowing the whole thing to work. Now the face of the striker is actually cut at an angle, so that way, and it's cut back, as you can see here. And the reason for that is whenever the bolt's locked up, or whenever it's not locked up rather, the carrier and the bolt are flush on the back. So the face of this striker cannot touch the firing pin at all until the bolt is locked up in place. And this angle sort of helps to ensure that as well. So even if it's almost there, if the carrier's on its way forward, whatever the case may be, this striker cannot physically touch the firing pin out of battery. So that's the other safety feature there. And moving back, we have the disconnector assembly. So the disconnector is jointed right here, and that allows it to reset. There's a spring on the bottom, a flat spring and a retainer there that pushes it back up into place. So it rides right here, and it folds down like this, catches the end of the striker, or the end of the sear, sorry. And, once the sear releases the striker, it comes down like that. Let's see if I can get this closer. So once the disconnector pushes down on the sear, passes it, it releases the striker, pops back up, and then this comes back up. It bends at that joint, allows it to reset. So the guide rod assembly, the disconnector, then we have the trigger link right here. The trigger link connects the disconnector to the thumb trigger with these two 1/2 inch long 1/8 inch pins. So these go down in there and sit on that trigger link. This is the link anchor. So this piece here gets welded to the backside of your thumb trigger, and that's where it essentially acts as an anchor for that link there. It's what links the anchor to the trigger itself, or anchors the link rather. But this long 1/8 inch pin is the pivot pin for the disconnector here, and it doesn't need to be this long. You'll have to cut this down, but we went with the longest pin. That way we could use the same pin for the SGMT or the KGKT / SG43 kits. So you'll have to cut that down, but that pin will end up here, and it'll allow the disconnector pivot point place to rotate. So the last pin is an 1/8 inch roll pin, and it is a stop point for the legs on the trigger return spring. So this is just an AR-15 hammer spring, and this surface here rides up against the backside of your thumb trigger, and these two legs rest up against this spring pin, and that's what will, whenever you let off the thumb trigger, that's what brings it back and allows it to reset. And yeah, so that's everything that comes with the basic kit there. That's really everything you need. We've simplified this as much as we could in order to the more parts something has, more complicated it becomes, and more prone it is to breakage, right? So we want a minimum number of parts, and we want to refine them to the point where they can just go and go and go without wear. So there will be there are drawings and various things included, breakdown diagrams like exploded views that show you how this stuff goes together. But this video is just sort of an overview to show you, how it works, what goes together, and whatnot like that. So that's the basic kit there. So if you're building an SGMT, no matter what, you'll get all this stuff, but you won't, like this link anchor, this link, and this hammer spring or trigger return spring you won't use in the SGMT. So whenever you get the SGMT is basically an add-on kit. So we make, the SG43 kits, all of them are the same. And if you select the additional option for the SGMT, you'll get the SGMT fire control cartridge. And this one's the prototype from my gun. If it looks a little weird and kind of beat up, but they'll be in the white. This one was Cerakoted black. So with this, you'll receive this housing, 2 of these 5mm spring pins. This one here is the pivot point for the trigger. The other one goes here for the guide rod. Basically, the guide rod will mount in here like this. And then a 5/32 pin up here for the safety. So 2 5mm pins, the 5/32 pin, the cartridge, and a different trigger link. So you'll get a shorter trigger link that comes with that as well. And that's the only difference really as far as additional manufactured parts that you would need. So from your SGMT fire control solenoid, there are some parts you'll have to take from that. This again is from my prototype, that's why this isn't blued. But this is the thumb trigger from the fire control solenoid on the SGMT. And if you notice, there's a slot cut down through the middle. That's to allow this link a place to ride. So it really doesn't matter as far as accuracy. It just needs to be clearance, but there is a drawing included for this. You'll have to drill this 1/8 inch hole through the side here. Goes through both sides in order to capture that link, and then just mill a slot down the center. And that's the only modification necessary for the thumb trigger. In addition to that, you'll need the thumb trigger spring. So it sits in this pocket right here. Like that. And that's the configuration you'll find it on the solenoid as well. And the other end of that spring will sit in this little pocket right there. And then it'll just, pivot on that spring pin. So inside the, whenever you remove this, you'll notice that there is a large, I guess, bushing, for lack of a better term, that goes through the center of this thumb trigger like this, except it's a whole lot longer. It's almost twice as long as this small section is here. So you'll need to take this and cut it down so that it's flush on either side of this thumb trigger, and that will reduce this hole down to 5 millimeters. So again, this bushing comes with your SGMT fire control solenoid, that electronic solenoid that goes on the back. So whenever you pull this out, this thumb trigger, you'll find this long bushing. Just cut it down so it fits in here, and you're good to go there. Other than that, the only other parts you'll need from your fire control solenoid will be the safety lever and its corresponding little torsion spring. So those mount on this 5/32 pin up here, so that when it's all together, you'll have, your thumb trigger back here. Safety bar comes up nicely through the top, and you just push the safety bar down and you can actuate the thumb trigger, and that'll all be spring loaded. So I've had people ask me if this will work with a standard SGM, and it will, but you need these parts. You'll need to get that spring, safety bar, the other spring, and the thumb trigger. Alternatively, you could make them. I have CAD models available for all these parts, and I'm just going to include them with the drawing package. I'm not sure that I'll actually make dimensional drawings, or at least not like manufactured level drawings, but I can give sketch dimensions, essentially enough information that somebody could make these if they needed to. And procuring the spring might be a little difficult, but outside of that, yes, it will work with the SGM, but these parts will be necessary because that's how the cartridge is designed to work. Alright, so moving on from the kit overview, we'll go a little bit into how you would build it, how it works, or the modifications you have to make, rather. But first, we'll start with a couple key specific safety points when building one of these. So first, whenever you build one, there's a very simple test to know if you're there or if you're not there. And by that, I mean, is your receiver functionally okay? I mean, is it to the point that you can start moving on to the modifications that we're going to go into or not? And that is something that in the amateur kit building community that we like to call the tilt test. So what you do, put your bolt and your carrier inside the receiver. Obviously, they would be modified for semi-auto use only before being clearanced around whatever denial feature you have in place. So at that point, you would just pick it up and you tilt it back. Make sure that the bolt carrier and the bolt come all the way to the back, and then tilt it forward, and they should lock in place. So back, trying to make sure I get it in view, forward. Without any resistance, they need to lock it into battery and then come back out again. So if your gun is not able to do that, stop, you're not there yet. You got to figure out where it's binding, what's crooked, what isn't quite right. Don't even try to pass go until that's happening. The next thing is when it comes to putting your barrel in place, get this back out. So whenever you put your barrel in place, and sometimes these, and this is the same for the SG43 as well as this SGMT. Sometimes the barrel lock is a little weird, like it's tight, or maybe it wasn't the one that was actually from that gun before it was demilled. Whatever the case may be, never remove material from this front surface here. This is actually tapered in like this, and it keeps this lock in place. So if you have to remove any material, and this is in the Russian armorer's manual as well. Remove it from this surface back here, or this top surface, or you can do the same thing inside the receiver, a little, very small amount at a time from this surface or the bottom side, until that lock slides in place. But never remove material from this front edge, because then the barrel lock can kick up and bad things can happen. Okay, so you've got a gun put together, and you know, bolt carrier, passed the tilt test, everything's fine. You know, you've got your barrel so that it fits, locks into place. You've got your headspace set, everything's working there. So now we're ready to move on to what we would do with this kit. So the first thing you want to do is the bolt and the carrier. All right, so we always recommend welding up. There's a notch in the bottom that the original, like, auto sear would locate into. Cut out a piece of metal, put it in there, weld that up, because it's no longer needed. It doesn't need to be there. We don't want it there. Get rid of it. From there, I've checked a couple of these, and this back surface isn't actually square to the bottom of this rail here. Not the bottom of the carrier, but the bottom of the rail that actually rides in, on the rails. So what I would suggest is set up off of this bottom surface right here, and just dust the back side of this with an end mill until you've got 90% cleanup or so on this surface, to make sure that it's nice and square. Because if not, it can hit the striker. Comes back in here like this whenever it hits that firing pin. Well, a lot of times the strike, if it happens that the back of the striker bottoms out in the receiver and the carrier comes back and it hits it, you want it to hit it square. That way it doesn't risk cracking the tube or doing anything like that. So first step, weld this up. Second step, just dust this off square to the bottom of these rails. The third step would be, well, actually you would have to do this beforehand to ensure it was semi-auto only, but machine down the top of this notch to 290 thousandths from this surface. So from here to here, you want an overall height of 290 thousandths. And it's somewhat critical in that this feature is what locks up the bolt, and you want to remove the minimum amount necessary, right? I mean, if we remove too much material from the top of this, what's going to keep this bolt locked in place? So 285, 290 is what I would go for. And again, you'll have to do that at the same time that you, actually before you clearance for your denial feature. That way you're not putting any original, you're not creating a machine gun conversion device. That would be illegal and not good. So after this is machined down, after that's welded up, got that square, denial feature clearanced, the carrier's done at that point. The bolt, this is that pin that holds the firing pin in place. Right there. So, make sure to drive that out, knock the original firing pin will fall back out the back. But all of the bolts have a hole all the way through the backside. They had to put it there to be able to get down in here and drill the other one. But that anti-bounce spring that we talked about, it rides right down in here. And we need to take this hole just a little bit deeper in order to make room for that spring at full compression. So the exact number will be on the drawing, how deep to go. But yeah, I mean, what I do is I'll just stand it up, bolt it to an angle plate, run an indicator up and down here to make sure I'm straight, and then just come down and put that hole a little bit deeper. Pretty simple there. So then after all of that stuff's in place, you want to take a look at the firing pin projection right here. So one thing, it was a real pain in the butt to try to figure out proper tolerances and lengths and standard sizes for all of these parts, because a lot of these guns are just a little bit different. So with that being the case, there's some special attention that has to happen as they're being put together, and this is one of those situations. So I've noticed on a KGKT bolt that I have, the firing pin is still protruding a little bit in its standard configuration. So whenever this slot, whenever the front of that slot is resting up against its stop pin down inside of the bolt, the firing pin is still sticking out the front of that hole a little bit. So you want about 30 thousandths. You want that firing pin to be recessed down inside of the bolt face. And in order to do that, just file this corner out here. Like there's a radius in it, but it's fine. Just file it out a little bit, fit it up, file it out until you get that firing pin recessed back in there, about 30 thousandths. So some bolts it isn't necessary, some bolts it is, but we have to make sure you have the information to be able to do it. And that's it for the bolt and the bolt carrier. So at that point, you've got functional operating assembly as far as that goes. So next step will be to put in the slot for the horseshoe retainer, so that you can actually put this assembly in there and start testing it from that point. So the slot for the horseshoe retainer is in the front of the receiver, right here. And it's a, what was it, 3/16 end mill, and it has to go down, I think, it's on the drawing. I think it's like 850 thousandths deep or 900 thousandths deep. So you'll have to get a 3/16 end mill with an extended length flute. It's still a standard end mill. They just call it extended length. So there's two ways to go about that, and the location for this feature and the information I'm giving you now is on the drawing to do this feature. So yeah, you can you pick up off of the front with an edge finder, and you come out and find the center, and you can where your feature has to be. The overall length of this slot to the end of the radiuses, not to the center line like they would normally be called out. They're called out to the outside, and it's the width of your horseshoe retainer plus 10 thousandths. And the reason I dimensioned them that way is so that we wouldn't have to hold such a tight tolerance on the overall width, because it doesn't really matter. I mean, each retainer gets cut for each gun anyways. So just check the outside of this with a pair of calipers, and you can cut this slot here, the overall length of it. It can be 10, 15, even 20 thousandths wider than this retainer. As long as it fits down in there, you're good to go. This one, you can see it's got some extra room in it too. So you can either start with a 3/16 drill or slightly under, and drill these endpoints on location, and then go back and work this slot out with your end mill, to get the slot in place. Or you can just go in with the end mill and sort of start slotting it out. What you'll want to do is go down the full flute length, or about 700 thousandths. Leave some at the very top. Do that first, then pop that end mill out of your machine, and grind a little bit of material off of the shank. Grind it back a little farther so you can go deeper with the end mill, but it doesn't rub on the shank inside this slot. And you only have to go back up the end mill like 1/8 of an inch or so. Should give you plenty of clearance. And then just come down in here, drop down, 30, 40 thousandths at a time, and just kind of work it back and forth. And it's really easy to get the slot in there. After the slot's in place, the gas tube has to be clearanced, as you can see. I think you can see. So the bottom of the gas tube is its original length, but the top of the gas tube has to be clearanced a little bit so that the horseshoe retainer can get down past it. And it's pretty easy to do. Just put it in a vise and run an end mill by it, take it out, put it in, check it. It's not too critical there. And you can just pin it in place and horseshoe retainer fits. So the 8 30-seconds set screw that retains, that keeps the horseshoe retainer locked in place. You can see it here on the front, right there. So it's not really that critical. You can center punch about the location it's supposed to be, scribe it with calipers or whatever, center punch it, and then just drill it by hand and tap it. Or if you're thinking ahead, before you weld this front section on to the second section here, you can put that hole in at that point in time. You could even do that slot at that point in time if you've got a long front section. Might make it a little bit more manageable in your machine. But whenever you drill and tap this, you want to have the horseshoe retainer in place so that you can dimple it through the other side. So, you can drill the hole through first, drop this horseshoe retainer down into place, and then put the drill back in, dimple the face of this, and then go ahead and tap your holes. So that way, whenever your set screw is tight, it's got a little dimple that it locks into, keeps everything nice and in place. So after that's done, you'll want to put the horseshoe retainer in place, lock it down, and put your charging handle in. If I can get it. There we go. Put your charging handle in place, put your horseshoe retainer in place, and then push the charging handle all the way up to the front. And if you look, my charging handle hits the back side of that horseshoe retainer, and that's fine. Yours is going to stop against that as well, but just make sure that it can actually go all the way forward. If you notice, there's a detent right here, locks into this slot, so make sure that's all the way in, locks into place, has a little bit of give there. You'll have to clearance the front of the charging handle to ensure that happens. Some people have been able to get away without clearancing it. It just doesn't need it, but it's really nothing more than a Dremel tool or a file or something to make sure that there's no interference there. Okay, so now that that's in place, that's really the only modification to the receiver itself. The rest would be in the spade grip assembly. And so yeah, other than that, the receiver's finished. Now, for the SGMT, obviously we have much less room than we would in an SG43. And that's why we need the cartridge itself. So as you can see here, the SG43 has a lot more material out here, a lot more room for activities, whereas the SGM does not. So we took all of this space that we needed because the SGM receiver is also shorter. We just took all the space we needed, shifted it back in order to make up for the difference in receiver length, and that's where it ended up. So I don't have an unmodified one here to show you, but this is sort of what you end up with here. You would machine out, like this pocket's already here, this main, the largest pocket you see. There will be like a boss in this section right here. You can see this half a hole. Yeah, so this used to be entirely enclosed, and there was a detent in the top here with a spring and a ball, or a spring detent that would keep this in place. So that would be the unlocked position. Locked position goes forward, and it keeps this locked in place. We have to machine all that away for the cartridge to go in, but it doesn't really matter because the cartridge keeps it in place anyways. So with the pull it out. With the cartridge in there, this lock can't come back out anyway. So that part doesn't really matter. So what you'll have to do is machine, well, you want to weld this up too. That's in the instructions as well. You'll want to put a plug in here and weld this in. But there, this pocket here is what you'll have to machine out. This one on the inside, the smaller one, and then this slot here. Machine this out because the sear and the new guide rod and everything will sit right in here like this. Inside of that cartridge, it locates like this. So that gives you room for the cartridge. It gives you room for the guide rod and that whole assembly. And again, there's a drawing that shows you all this stuff. These are the original pins that would have held in the fire control solenoid, and they will be reused to hold the cartridge in place. So after you get all this machined out, these holes here and here are what lock it in place here. These are either going to be drilled undersize, or I'm not going to drill these, and then you'll drill them whenever you get your housing in place. And that way you can, you want it to be pushed in all the way, nice and tight, and up as high as it'll go, and kind of locked into place, and then put those holes through. So that way the cartridge is locked in place in a repeatable location every time. You don't want it to be sloppy or anything. So that's the next step. You want to go ahead and machine the pocket into the spade grip housing, and then drill those mounting holes so the cartridge can go in place. So after that's done, from that point you'd have to work on the sear. So, well, you'd want to assemble go ahead and assemble the cartridge, get your trigger slot cut, put that hole in there, assemble the unit, make sure everything moves like it's supposed to. Whenever you're putting this stuff together, we always recommend staking the pins, and by that you can kind of see the dimples around the hole here. So just center punch, an automatic center punch works great for this. But that's actually how a lot of these guns were built. As you go through your kit, you'll find plenty of pins that were staked into place. Just keeps them from backing out. It keeps everything sort of locked in where you want it to be. So after you've fitted everything and you know that it works fine, take it back apart once again, and then as you go through and assemble things, stake the pins into place. Okay, so once it's all assembled, you'll have the disconnector and this sear face. So this is the most critical part of this whole build here, and it's not necessarily hard, but it's time consuming. Think about something like fitting a new trigger to a 1911, right? It's fiddly, it's gunsmithing, it's real gunsmithing, and that's sort of where this fit comes in, because the disconnector needs to pass the end of this sear. It needs to push it down, pass it, come back up, trip, reset, and do that functionally, repeatably every single time. So the tolerance between the end of this and the end of the disconnector here is pretty tight. So what we do in order to make up for any out of location condition is we leave extra material on the front of this. So on an SGMT, you're going to want the distance from the back side of this here to the front side of that line we need to change. You'll want it to be about 520 thousandths. On an SG43, it'll be about 530 thousandths, and those are perfect numbers. So if any of the holes you drilled are out of location, just slightly, or the pocket maybe isn't as deep in that as called out for, again, by thousandths, those numbers can change. So that 520, 530, those are just sort of rough guidelines. Overall, we leave 540 thousandths between the back side of this and this front side here to leave you material to remove from this. So it'll almost be guaranteed that you'll have to do this operation, but that's okay. I mean, that's how we get the best results possible. And what you'll want to do is stone this smaller face. Let's come around here. So the smaller face here, keeping it at the same same angle from this top. Just file it, stone it back a little bit. You can remove a little bit from the top if you want, from the face, from the top, and then you'll want a blunt edge here. So not a razor sharp corner, obviously, because that's too weak, but just roll it over a little bit, 5 thousandths or something corner radius right over this top edge, and the parts will last indefinitely. I mean, they really don't wear on each other. So I would start by removing 5 thousandths from this edge here, and then put it together, push the trigger, test it, remove another few thousandths, push the trigger, test it, until you get it to break free and reset. And it might be hard. It might be like, you're pushing the trigger and then you push it free. So that's not where you want it. You still want to take off just a little bit more, but you're almost there at that point. Until it's nice and smooth. It should, if it's a little stiff in the beginning, that's okay too, because as you run it, it'll wear in. But that's pretty much it for the basic install. There are some differences on the KG-KT, and I'll cover those in another video. I guess we could go over the modifications necessary for an SG43 fire control assembly here. So the first thing that you want to do, this location here, this hole for the guide rod, we're going to have to move this hole. So there'll be a small plate that comes about the same width as this and a little bit taller. It'll be about 20 thousandths wider than it needs to be. It's a laser cut piece, so just sand hit it on a belt or disc sander, use an angle grinder or whatever, to knock off that laser cut edge, so that it's easier to weld and to deal with. And you'll follow the drawing. You can set it up like this and clamp it in place in a vise and run an end mill down across here to remove, I think it's about a 1/4 inch deep, 750 the other way, or an inch, something like that. And then you'll put that plate into place there, weld it in, and what it'll do is it'll give you material to move this hole down. And all of the hole locations come off of this central takedown hole. So after this is welded into place, you can clamp it in a vise, and you'll have to drill, kind of like as shown here. There's the hole for the pivot location for the disconnector. So it'll be up here. You'll have the disconnector location hole, the guide rod hole, which will be right about here, and that spring pin that the legs of the trigger return spring push against, and that one goes down here. That hole doesn't really, you could put it in there with a hand drill, it doesn't matter. But this guide rod hole and this disconnector hole, those are the critical ones. And they're called out on the drawing, I think ±5, which will leave you enough location that you can, or enough room that you can still get the sear, fitted in place, and everything works fine there. That's pretty much it. Once you get to that point, you can dry fire it, test fire it, and run it how you would normally break in and test and assess any new weapon that you build. I don't really think I have any other information at this point, but yeah, if you have any questions, feel free to reach out, and we'd love to talk to you. All right, thank you.